Okay, so this is problem 17 of chapter 20 of Giancoli 6th edition. So we have a doubly charged helium atom. Okay, so what they're giving us is the charge of this helium atom by saying that it's doubly charged. That means we have 2 times the charge of the proton. Okay, so with this information they are giving us the charge of this helium atom. They also give us the mass of this atom. And what else they tell us? They say that this atom is accelerated by a voltage, right? Since it's doubly charged, it gets accelerated by a certain voltage, which is also given to us. Okay, with this, they want to know what will be the radius. So the first question here is, what is the radius of curvature if this atom moves in a plane perpendicular to a uniform field, a magnetic field, and they also give us the value of this magnetic field. Okay, so the idea is this helium is coming, let's say, to the right with a certain speed. It reaches a region with magnetic field perpendicular to that speed, and because of this it will feel a force, a magnetic force. Now, so it's going to the right and the field is into the page, so it's going to feel a magnetic force pointing up, and because of this magnetic force it will then start moving in this circular motion. Okay, so we have here a magnetic force that causes this uniform circular motion, and we want to know what is the radius of this motion. Okay, so how do we find that? We know that, well, the magnetic force will cause this circular motion, so this magnetic force is ma. A here is the centripetal acceleration, uniform circular motion, no? So it's the centripetal acceleration v squared over r. And what we want to find is this radius here. Okay, what is this magnetic force? This magnetic force is the charge of the particle. This is given to us, is twice the charge of the proton. Okay. Q, V, the speed of this helium, QV, B, the magnetic field. And this is equal to m v squared over r, so we can cancel one of these v's, but we are still in trouble because we don't know v. If we knew v, we would be done. We could just find the radius from this equation. So but the v, the speed, is missing. But remember, they gave us the potential difference, and because of this potential difference, this particle, this atom, is being accelerated. So because of this potential difference, it has potential energy, and this potential energy is going to be transformed into kinetic energy. So what is this potential energy? The potential energy is Q multiplied by the potential difference. Let me make this Q a little better, right? So Q, the charge of this whole atom, V, here this big V is voltage, so this is the potential difference, which will be transformed into kinetic energy, 1/2 of mv squared. So now you understand why they gave us that mass. So we have the charge, we have the voltage, we have that mass, and so from here we can find the speed of this atom, and with that speed we'll be able to find the radius. Okay, so this is part A. Part B is what is the period of the revolution. Well, this is uniform circular motion, and we know very well that the speed is given by the circumference, 2 pi r, divided by the period. Everything we have except for the period, so now we can find it.